Role of muscles. Depending on the situation, the muscles can perform various functions such as agonist. It is the muscle or muscle group that causes the movement. It is also called the main muscle. When a muscle participates in a movement without being the main promoter of the movement, it is called secondary, synergist. These roles are defined by factors such as traction angle, leverage and contraction potential. Antagonist. It is responsible for the movement opposite to that of the agonist. Stabilizer. These are the ones that firm a part of the body to allow the movement of a more distal segment. Neutralizer. Prevents the contraction of a muscle and/or its line of traction from promoting the occurrence of unwanted movement. Note: according to Suchard, there is no complete antagonism, because all the muscles called antagonists, in reality do not have their insertions millimeters apart. What actually occurs is a complementary action in which the forces act to generate a precise movement. Strict antagonism would make any coordinated plurisegmental movement impossible. One can say then that the complementary aspect predominates over antagonism. Muscles of static action x muscles of dynamic action. The muscles of static action. Asterisk they produce strong traction that generates small displacement. Asterisk their fibers are short and arranged obliquely in relation to the tendon. Asterisk they have a prevalence of oxidative fibers. Asterisk they have a greater amount of connective tissue. Asterisk they almost always act against gravity. Asterisk examples of static muscle chains: posterior, inspiratory and superior shoulder chains. Muscles of dynamic action. Asterisk they produce small tensions that give rise to large displacements. Asterisk consist of long, parallel fibers that extend in the direction of the tendons. Tendons. Asterisk they have a higher proportion of glycolytic type fibers. Asterisk examples of dynamic muscle chains, anterior of the lower limb. Levers. In physics, levers are efficient methods of maximizing energy in performing work that involves overcoming a difficulty. The human body uses them to perform a large number of activities. A lever is composed of a rigid bar, a fixed point, a point where force is applied, and another point intended to overcome resistance. In the body these are represented by the bones, joints. There are three classes of levers, each with its own mechanical advantage and specific function. First class, interfixed. The fixed point is located between the point of application of force and the point of resistance. In the body it is exemplified by the atlanto-occipital joint and provides balance. Second class, interresistant. In this lever, the resistance is located between the fixed point and the application of force. Its example in the body can be represented by the calf muscles lifting the individual who stands on tiptoe. Third class, interpotent. The power lies between the resistance and the fixed point, as for example, the biceps brachii acting on the elbow fixation. Its advantage is to allow wide movements with rapid movement of the extremity of the segment. To calculate the mechanical advantage offered by a lever, the force arm is divided by the resistance arm, being the resistance arm between the point of resistance application and the fixed point. The arm of is the distance between the point at which it is applied and the fixed point.